Okay. Phones off. Okay, comrades, I am delighted to welcome Bill McGuire to Communist University. Bill is going to be given a presentation based on his wonderful book, Hothouse Earth. And he does have another book coming out. It's just been announced in the spring called Fate of the World. But I'll hand it over to Bill to take it away. Thank you.
Thanks very much, Tam. No, nothing.
Okay, I'll remove that for you. I know you don't like having disruption.
Doesn't work. It stopped working. Yes, I know, listen. It worked before, they're not working now.
Picked it on maximize.
Yeah,
just
game.
like you gain focus of the screen.
We'll get there.
Slowly but surely. If you can click through.
Great to be here. Thanks very much for inviting me. What I'm going to talk about really is what it says on the tin, Hothouse Earth, an Inhabitant's Guide. The bottom line is we will face hothouse conditions in the future. There's nothing we can do to change that now. It's too late. How bad things are going to get is the only issue. And as an aside, we can't really look at any issue at all unless we look at it through the lens of climate breakdown, because our future is going to be predicated on how bad that's going to be. So whatever issues you've been addressing here over the week, climate breakdown should have been there right at the forefront, because that is the world, that's the background against which our society and economy are going to continue to operate or not, as the case may be. I wrote Hothouse Earth after the COP climate meeting at Glasgow a few years back, where it was clear that all the talk was still about keeping the global average temperature rise since pre-industrial times below 1.5 degrees, even though at that stage everybody knew that was impossible, and it's even more impossible today. So this is really what got me writing. 1.5 degrees as a temperature rise is critical, because everything above that equates to dangerous or pervasive climate breakdown. Once we go above 1.5 degrees, things get extremely difficult. Climate breakdown starts to interfere with every aspect of society and economy. 1.5 degrees now is dead in the water. It's the temperature, the global average temperature rise has been above that last year and the year before that, and it's unlikely to drop below that again. So we're there now. Effectively, we have already returned to a prehistoric climate. What this means is, yes, we have to slash emissions, because a dangerous future doesn't necessarily have to end up as a cataclysmic one. So that is still absolutely critical. Even so, we're still pumping out 37 billion tons of carbon dioxide a year from burning fossil fuels. There's no sign at the moment that that will go down in the near future. But as well as slashing emissions, we have to adapt. We're facing a completely different world in the decades ahead. Most people just haven't taken this on board because they think tomorrow is going to be like today. Well, it often has been over the last 50, 60 years, but no longer. And the question is it already too late for effective adaptation? We can adapt to a very different climate change world, but only to a certain extent. So I'll come back to this at the end of the talk. What is our future world going to be like? What are we going to be facing? How can we try and adapt to that. This is a graphic which shows the global temperature over the last 30,000 years or so. You can see it at its lowest coming out of Ice Age and then plateauing, dropping down a little bit into what might be the next Ice Age, which is now postponed for at least 500,000 years by our activities. And you can see what the temperature has done over the last couple of hundred years, mostly in the last 50. And in fact, that should be quite a bit higher now. A couple of key points here. Carbon dioxide levels were 280 parts per million in pre-industrial times. They reached 430 in May this year. Annual emissions, 41 billion tons of carbon dioxide. That's equivalent to the weight of 800,000 Titanics, just to give you some idea of how much we're pumping out. We pumped out just over 2.5 trillion tons of CO2 since the Industrial Revolution. Temperature rise last year globally was 1.62 degrees, so we're way above 1.5. I mean, when people talk about exceeding 1.5, they normally mean over a longer term, but we're already getting into that long term now. The last 10 years were the 10 hottest years. That tells you something about the trend that is going on at the moment. Temperatures are now rising faster than at any time in the entire 4.6 billion year geological record. They've been hotter in the past, obviously, and colder, but temperatures have never risen this quickly. So what have we got in the immediate future to look forward to? Well, there's a 70% chance that over the rest of this decade, the average temperature will be above 1.5 degrees. There's a small chance it might even get above 2 for 1 or more years during that period. So temperatures are really shooting upwards. The rate of temperature rising has doubled in the last 20 years or so to about 1/3 of a degree per decade. And that means that 2 degrees C could be permanently exceeded as soon as 2030s. Remember that we have in this country and many other parts of the world this goal of reaching net zero emissions by 2050. By the time we get to 2050, we may not have a society or economy that can actually accomplish that sort of thing, any of these big projects or big initiatives. Things are just moving too quickly. Global temperatures are already set to stay elevated for several thousand years. If we stopped all emissions today, that wouldn't make any difference to the temperature. It would stay there for tens of millennia. It takes a long, long time to come down. If we continue as we are doing, then you're looking at 500,000 years or so before the heat starts to come back to pre-industrial levels. So we're locking in a completely different climate for thousands of generations in the future. There may be a miracle in the next few years, you never know. This is greenhouse gas emissions against time. Past human emissions are shown in the black. You can see what would have to happen within the next 4 and a bit years to have any chance of staying below 1.5. And when I say any chance, effectively we've passed that anyway. 2 degrees, that's not going to happen. 2.2 degrees, that's not going to happen. Emissions are never going to do that in the next few years because they are locked in through the policies of fossil fuel companies who are actually expanding operations rather than cutting them back. Governments as well will refuse to hold fossil fuel corporations to account and prefer to hold those who are demonstrating against fossil fuel burning to account instead. So these scenarios are not going to happen. At the moment, we're sort of on track, according to the IPCC, for just under a 3 degrees C global temperature rise. But if you include feedbacks and things that we don't really know about or haven't pinned down well enough in the natural world, then you could easily be up to 4 degrees and well above that. So we're heading back to the future. This is a graphic of temperatures going back 65 million years. And the temperature curve is the one you can see with all the little ups and downs on going from quite high over here on the left, right the way down across the course of about 50 million years. Now we're unwinding that now. We're going to end up with a climate that's either Pliocene, 3 million years ago, Middle Miocene, something like 15 million years ago, or worst case, back to a period known as the early Eocene, 55 million years ago. Those are the choices. That's where we're going, one of those three. I'll come back to that at the end. Now, the whole climate change, climate breakdown, global heating can be summarized. It can be put in a nutshell, if you like, and that's something known as the Earth's energy imbalance. That's a comparison of the amount of energy coming in from the sun with the amount of energy going out. They should be about the same. Again, along the bottom here, you've got age going all the way back to 150,000 years. And the colors there, the orangey colors and the blue, they mark changes in the Earth's energy balance. When there was more energy coming in than going out, they're sort of orangey. When there was more going out than coming in, they're blue. And these are the ice age periods here, where it was just going up and down a little bit around about zero. Look what the Earth's energy balance has done between 1971 and 2020, and then over the last 3 years. It's staggering, astonishing, unbelievable that over 150,000 years it virtually didn't change, and now you have this enormous imbalance. And that's because the sun's radiation still keeps piling through our atmosphere, but it can't get out again because of the thickening greenhouse gas blanket. So the heat is being kept in all the time. Fortunately for us, 90% of that heat has been absorbed by the oceans. Otherwise, we wouldn't be here to listen to this and to talk about this. But that can't carry on. The oceans can't keep absorbing heat infinitely. What are we doing? Well, there are lots of climate change cartoons. This is the best one, though. I mean, this is absolutely spot on. We agreed to sign a pledge to hold another meeting to consider changing course at a date yet to be determined. That describes the COP climate conferences, which have been going on for 30 years. Absolutely. There's discussion, there's sort of several days of discussion, fairly leisurely. Then towards the end, people start panicking because they think we've got to issue a communique, but we haven't got anything to put in it. And so they rush around trying to find something to put in it. And they end up with this cobbled together communique at the last minute, which says bugger all. They may have pledges and or promises, but nobody's held to those. And fossil fuels are never mentioned. To get the word fossil fuel in a communique has happened a couple of years ago when there was a pledge, a vague pledge to wind down fossil fuels, but no commitments or anything. Now that was seen as a great achievement. The words fossil fuels were actually mentioned. This is because the last few COPs have had several thousand fossil fuel representatives in the bloody meeting. I mean, they as well as 1.5 degrees being dead in the water, this whole climate process is dead in the water. It doesn't work. Emissions have carried on going up year after year after year for the 30 years of the COP climate conferences. So they haven't done a thing in terms of reducing emissions. Now, one of the reasons 1.5 degrees is so important is because it's a temperature which a number of key climate tipping points are expected to happen. Tipping points are sudden, relatively sudden changes in the climate system. For example, the collapse of the West Antarctic ice sheet down the bottom there, or the collapse of the Greenland ice sheet. I've ringed 4 of them here. The shutdown of a set of currents in the North Atlantic called the subpolar Gaia, and the abrupt thaw of permafrost in Canada and Siberia. These are points of no return, effectively. Once they start, whatever we do in terms of reducing emissions or temperatures, they will carry on. And around 1.5 degrees, possibly even less than 1.5 degrees, these 4 will be triggered. And that means they're locked in effectively. So I'm going to look at the polar ice sheets and the permafrost and also the Atlantic currents, just to say a little bit more about these. Now, the thing about when we talk about the global average temperature rise of 1.5 degrees, that is an average for the whole planet. At the poles, the temperature rise is 4 to 5 times that. And it's higher over land as well. Temperatures on land have already gone up more than 2 degrees. So at the poles, you're seeing extremely rapid heating. The melting rate now is 6 times what it was in the 1980s. And in total, if you take all the ice that's melted on the Earth between 94 and 2017, that's 28 trillion tons of ice. That's the equivalent of, in terms of meltwater, equivalent in terms of ice of burying the whole of the UK under a 100-meter thick layer. A huge amount. And just the Greenland ice sheet is shedding about 400 billion tons of ice a year. But to give you an idea of what sort of volume that is, 1 billion tons of ice is pretty much a cubic kilometre. So 400 cubic kilometres of ice a year is being lost at the moment. One of the biggest worries is that the East Antarctic ice sheet glaciers are on the move. Antarctica has got a range of mountains going across it. You can probably see certainly the bottom part of Antarctica there. On the left, you've got the small West Antarctic ice sheet. On the other side, you've got most of the ice, the East Antarctic ice sheet. That was thought to be stable to temperatures much higher than we're seeing today. But around the margins now, the glaciers are beginning to melt already, which is a real concern. If all the ice melts at both poles, then we're looking at a 65-meter higher sea level. That would bring the sea into Derby, which is pretty near where I live in the Peak District and right in the middle of the UK. Ice sheet tipping points are about 1.5 degrees. They might even be as low as 1 degree C, in which case we've already passed the tipping point. So we are committed to losing Greenland and West Antarctica. That's a 12-meter sea level rise. Here's an example here of just one glacier, this giant glacier in Antarctica, the Thwaites, which is one of the most rapidly thawing. That alone would raise sea level by 2/3 of a meter. Now, if all this ice is melting, it should be reflected in sea level rise. Again, you've got time along the bottom, 1900 to 2020 millimeters up the side, and you can see how the average sea level rise rate is increasing. Between most of the 20th century is about 1.5 millimeters. It started to accelerate in the 70s. Now we're up in 2014 to 2019. It's half a centimeter a year, centimeter every couple of years. That doesn't sound like much, but just a centimeter or so means that hundreds of thousands more people, millions more people across the world are more susceptible to coastal flooding. And the doubling time looks as if it's 20 years or less. So, you know, if you've got a centimeter rise, a half centimeter rise now, then that goes to 1, then 2, then 4, then 8, and you soon get up into the 2 or 3 meters by the end of the century or just afterwards. Now, I'm sure some of you have seen the film The Day After Tomorrow, have you? Which has sort of an ice age within 6 weeks sort of thing. Well, that film started off rooted in science, and to the degree that the system of currents in the Atlantic here, called the Atlantic Meridional Overturning Circulation, or AMOC, they keep as warm currents, Gulf Stream and North Atlantic Drift come up, they keep Northwest Europe warmer than it otherwise would be. And when this system shuts off, it gets much, much colder in our part of the world. That SPG there is a little separate part of the AMOC called the subpolar gyre, which is weakening dramatically as we speak even. So this is a big worry, and has been a big worry for the last few years, that this whole system of currents will shut down as it has done in the past. Now, it's had its weakest for at least 1,500 years, and probably about the last 11,500. That's going back to the end of the last ice age. The latest shutdown forecast is somewhere between 2025 and 2090, with 2050 as the central estimate. But the truth is we have no idea when it's going to shut down. But all the latest forecasts and models have suggested it's going to happen relatively sooner rather than later. The tipping point, when this clicks, this switches itself off, could be as low as 1.4 degrees, in which case we've already crossed it. Now, in terms of implications, you would see severe cooling across Northwest Europe. It may be impossible to farm in the UK and Europe under the new conditions. You'll see temperatures down in Norway to -50, temperatures down in the southern UK down to -20 in winter. Who knows what Scotland will be like? And the sea ice will come all the way down to the south coast of the UK. So, literally polar bears will come down on that. They'll be having a great time after sort of, 100 years of global heating. But, devastating it will be. And this is, it's not certain, it's virtually certain to happen. Along the east coast of the United States and Canada, you'll have a very rapid sea level rise because the currents that are up to now are coming north will just stall. So the water will keep piling up behind and the sea level will rise significantly along that part of the coast. And then there are knock-on effects right across the global weather systems. So the monsoons in particular will be impacted. So you'll have much more in the way of severe drought, much more in the way of severe torrential rain and flood risk. The third tipping point I wanted to say a little bit about is the great thaw. Canada, Siberia are frozen solid pretty much, northern parts of them anyway. So the ground's frozen solid, permafrost. It's now beginning to thaw, and there's lots of methane trapped underneath that, which is coming out. And the seabed as well in the northern latitudes is also frozen. So that also has permafrost. That's also thawing, and methane is starting to bubble up from underneath. Methane is incredibly effective as a greenhouse gas, 86 times more better at retaining heat than carbon dioxide, but it doesn't hang about as long, 20 years or so instead of 100. But there could be 1.4 trillion tons of methane locked up beneath the Arctic submarine permafrost. And there is a concern, there have been a number of papers published in the last 10 and 15 years saying we could get burps of methane just happening in one go, 50 billion tons coming out. That would actually increase the methane content of the atmosphere 12 times, virtually overnight. And that would bring global heating forward 30 years. That's a stroke. Now, these burps are still controversial because looking back in time to periods of heating, there's no evidence of these sorts of things happening. But the absence of evidence is not evidence of absence, and the evidence may just not have been found yet. But even so, methane is still coming out of the permafrost in ever-increasing amounts. So it's still a big issue that the more methane comes out, the higher temperatures go up. This is a feedback effect. You heat the planet, you get thawing permafrost, more methane comes out, that heats the planet more, and it carries on like that. That's why it's a tipping point. Everything I've talked about so far is to do with physical processes, but probably the worst thing about climate breakdown is as a threat multiplier. It makes everything that's already bad worse. So it will impact, we know it impacts on the weather, so we're seeing supercharged extreme weather now. I mean, famine and food security have always been issues in different parts of the world. That is being made far, far worse. Health and mental illness as disease spreads into new parts of the world, as temperatures rise, for example. Mosquitoes carrying West Nile fever were found in Nottinghamshire a couple of months ago. And that's part of the movement of mosquitoes and the diseases that they carry with them into more temperate or what were once temperate parts of the world. And of course, war, civil unrest, climate breakdown is a real driver and will be a real driver of those. And in terms of extreme weather, I don't want to go into all the different types of weather. We can see that on our TV screens every day. You can see these events, shocking events. I just wanted to focus on one thing, and that is a particular type of heat. We all know, I think, that dry heat doesn't feel as bad as very humid heat. Now, humidity and heat are measured together on what's called a wet bulb thermometer. And a temperature of 35 degrees C on a wet bulb thermometer is unsurvivable for human beings. If that persists for long enough, you will live for 6 hours maximum, because the body can't sweat above that temperature because of the humidity. So you can't lose heat. Your body just heats up and heats up. Your organs fail and you die. And it doesn't matter if you're incredibly fit, incredibly young, in the shade, or whatever. It won't make any difference unless you're in an air-conditioned space or have access to that. Outside, you cannot survive. Now, these conditions are not common at the moment. They are recorded in parts of the world, the usual suspects, really: Australia, Mexico, Gulf area, Southeast Asia, but they're becoming more and more common and more critically, longer lived. I mean, if you had these conditions for an hour or so, then, it's not so bad. Quite often, when heat and humidity is like this, you get thunderstorms building and they reduce the heat and humidity, and so things cool down a little bit. But those conditions won't be around. Those short-lived conditions will translate into much longer-term ones, where if you're working in the fields, then you have nowhere to go. And the most at-risk area for decades to come that's been identified is the North China Plain. This has 400 million people working in agriculture. It's irrigated, so the air is very humid because there's so much water around. And if you have a day of these conditions, these people have nowhere to go at all. So you're looking at the potential for millions of deaths happening in just a matter of hours. Climate wars. Well, it shouldn't surprise you to understand that a climate change world will be a far more dangerous world. People will be fighting over pretty much everything: water, food, land, mass migration, resources. I've put the picture of the Arctic up here because this is one of the ground zero areas, if you like. Because the ice is melting, sea ice is melting, the northwest and northeast passages are opening up, so they're being used now as shortcuts between the Atlantic and the Pacific. More resources are being opened up, more oil and gas resources. So unbelievably, people want to get at more oil and gas so they can make things even worse. But the point is that the Arctic nations, Russia, United States, Canada, etc., are keen to get hold of as many of these resources as possible. China is also interested, even though it's not an Arctic nation. So is Japan, so is India. In fact, everybody is. So that's, this is clearly a point where we could have future conflict. And I know NATO have been undertaking military operations up here in cold conditions. So this is an area to keep an eye on for the future. But the really, probably the worst place in terms of future war is South and Southeast Asia, particularly India, Pakistan, and China. All these countries desperately rely on the Himalayas and the Hindu Kush glaciers for water, which they use for irrigating their farmland, and which feeds their people. But even at 1.5 degrees, a third of those glaciers are going to go, and we're not going to stick at 1.5. So most of the glaciers will go eventually. And all these rivers, the Indus, the Ganges, Mekong, Yellow, Yangtze, they provide the water to grow crops for 2 billion people. What's going to happen when those rivers fail? Now, to start with, failure won't be a problem. What you're going to get in the next few decades is increasingly catastrophic deluges as glaciers melt. The meltwater ponds in whatever available hollow there is, and then eventually it overtops or breaks through, and you will get these catastrophic flash floods, glacial outflow floods, they're called. So that's going to be an issue in the coming decades. But then beyond that, the rivers will just start to fail. And it's not only water that's a problem. There are loads of dams on these rivers. They provide a lot of the energy for these countries. They will no longer be able to produce energy because water levels will be too low. So you're building a situation here where there are going to be increasingly growing competition for water and power resources. And the thing about this is you have 3 nuclear powers here. That's the worrying situation. food is going to be the great driver of all our problems. Just last month, the UN said that severe drought was pushing tens of millions towards starvation already. Agricultural productivity since the 1960s is down by about a fifth on what it would have been if we hadn't got climate breakdown, if there hadn't been global heating. And this is a terrifying statistic. By 2050, the world will need 50% more food, but crop yields could be down by 30%. Now, it doesn't take much calculation to understand that that is essentially a halving of available food per head of population on average across the planet. I mean, how is society and economy going to cope with that? I'll mention who this chap is at the end of this slide. But what's absolutely clear is that accelerating climate breakdown is translating into massive, persistent social and economic shocks. I mean, we're only just beginning to see these things. Crop yields and food supply are already taking a hammering. And in just recent years, you've had coffee, you've had cocoa, and you've had vine agriculture taking hits. And forget everything else I'm talking about, but a world without coffee, wine, and chocolate is just doesn't bear thinking about, to be honest.
We can sell, Bill.
By 2050, extreme weather losses are expected to be $38 trillion a year. That's a third of current global GDP, pretty much. And it could well be much higher because these things are always being underestimated. There's something called the Human Development Index, which some of you may be aware of, which is set up to record the progress, whatever that actually means, of nations across the planet. Well, for the last few years, it's been heading down. In 90% of nations, it's heading down. So whatever that progress definition was, it's going the other way now. The World Bank has pointed out that the global economy in the 2020s is growing at the slowest pace since the 1960s. And already, effectively, the world is going backwards. So, you know, you can talk about shiny stuff like space travel, artificial intelligence, all these other things. But under these given these sorts of trends, you might want to think about who's going to pay for these things in our future society and economy. This chap is Arthur Henry Lewis, journalist and writer, American journalist and writer, who is famous for saying, I don't think anyone knows anything else about him, but in fact, he said, there are only 9 meals between mankind and anarchy. I mean, if you can't find food for your kids for a couple of days, you're not going to go to work, are you? You're going to go out and try and find food. Things very rapidly start to fall apart. And in my case, that would be 3 meals, by the way. And my message is, well, you might think it's gloomy. I would say it's realistic, and it's not just me. 2023, 15,000 scientists signed a letter warning of the risk of societal collapse from climate breakdown. 2024, King's College London and the Fairness Foundation highlighted the potential for societal collapse within a decade. 2022, there was an update of the limits to growth. Some of you again may know about this. It was a computer model developed in the 70s, which looked at our progress, again in inverted commas, over the next century or so, and predicted collapse because we'd use up resources, we'd increase pollution, and all these other things, inequality, etc. The collapse, societal collapse, was inevitable. And the update in 2022 says, yeah, it's exactly the same now. That's still where we're headed. And the latest update talks about collapse as soon as 2040 for business as usual. And then the most recent one this year was a report from the UK Institute and Faculty of Actuaries alongside University of Exeter. The actuaries are not known to be people who sort of exaggerate hyperbole, etc. You know, I think there's something about actuaries being failed accountants. I'm not sure. There's some skit about that. Anyway, their report predicts that for a 2 degrees C global average temperature rise by 2050, we will see a 25% collapse in global GDP and 2 billion dead. If we reach 3 degrees C, it's 4 billion dead and a 50% collapse in global GDP. And we're on track to hit 2 degrees C in the 2030s. So increasingly, it's being recognized that we cannot carry on as we're doing at the moment. It's impossible. So where are we going? I'm nearly finished now if you're feeling too depressed. Which future are we heading for then? Well, we've left the safe space of the Holocene. The Holocene is the time, the last 12,000 years, since the end of the last ice age. It's the time our civilization developed. That the conditions that our great-grandparents lived under and everybody before them. That's gone. We've already rewound the climate to the previous interglacial about 120,000 years ago, called the Eemian. We're back there now. Temperatures about 1.5 degrees higher than pre-industrial times. But we're not staying there. The best case, the best we can hope for, is a return to Pliocene conditions about 3 million years ago. That's about 3 degrees C hotter on average. All the coastal cities will be drowned because you're looking at sea level rise here of maybe 20 meters. Eventually, it will take time. And much land, particularly in the tropics, will be uninhabitable. That's the best case. More likely is a return to Miocene conditions, the heat of about 15 million years ago, which really is pretty much the same, only hotter. You're looking at maybe 7 to 8 degrees C hotter on average. Conditions then may involve the complete melting of all ice on the planet, which would push the sea level up to 65 meters above what it is now. And the worst case is a return to the Eocene hothouse 55 million years ago. That's a global average temperature rise well into double figures, which would make the average temperature of our planet 30 degrees C. That's the average, winter, summer, day, night, whatever. That would make much of our world uninhabitable for humans. And that would certainly destroy human civilization and set us on course for possible oblivion. So what's going to happen next? What are we going to do next as a society and economy? Well, I think there are 3 options. If anybody can think of another one, please let me know. Option 1, which I don't think is very likely, in the face of devastating climate breakdown, we somehow manage to hold things together while we burn through a huge chunk of unused fossil fuel reserves. So we drive emissions through the roof, above 1,000 parts per million or something like that. The second is we experience a Damascene conversion. All of a sudden, we think, God, why are we doing anything? We need to act. And within a couple of decades, we slash emissions. We see emissions coming down to near zero. And then the third option is that we soldier on pretty much as we're doing now. Things start to quickly unravel, as they already are doing, under the onslaught of extreme weather. Free market consumer capitalism sustaining global heating falters, eventually fails, and as a consequence of that, we get societal and economic breakdown, as these various reports have predicted, and that itself results in plunging emissions. So in a sense, these two and 3 here have the same end product. We'll end up either with a Pliocene climate or a Miocene climate, depending how lucky we are. They will still be horrific. We'll still see billions of people dying, but the saving grace is it won't be as bad as option 1 if we follow that path, which I don't think is likely. With these 3, I can't see it. I see no sign of 2 at all. There is no sign of 2 happening. Whereas there is a lot of evidence that we're heading for option 3 here. So in a sense, that's sort of good news. It's not the worst possible case, but it is pretty awful. But again, a reset a reset of our society and economy, bringing something different that isn't capitalism, which, you know, based upon greed, short-term profit, environmental destruction, exploitation, is responsible for all of this, for the mess we're in. Maybe a reset will not only ensure that the human race survives, but also that ecosystems can recover and that the earth itself comes back to its normal situation, and we learn something from it and we move on ahead in a completely different situation, completely different path to what we've been doing over the last couple of centuries. So I don't necessarily think it's all bad. It's not brilliant, but it could be worse. And I'll stop there. Thank you. Oh, hang on, I've got a quote somewhere. Yes. This is Ralph Waldo Emerson, great US poet, essayist and thinker. The end of the human race will be that it will eventually die of civilization. Well, you know, he's right. We're not dead yet, but that death is coming closer because of civilization. But societies have collapsed before and come back, and I would hope that maybe we can do the same thing with a much better one. And I'll stop there. Thanks very much.
Thanks, Bill, I think. Okay, comrades, what we do now, Bill, is people make contributions or ask you questions, and a good bit of time to go. We'll take a number of these and then we'll see where the point where you come back in rather than answer everything as it goes along. So Mike is up first. Yes, then you.
Yeah.
Thank you, Bill, for that illuminating and depressing story. I'm going to one thing a little bit even more depressing, which is my understanding of the policy of the United States towards this question